Picture a Scottish river on a clear autumn morning. Water running cold over grey stone, the banks empty, the pools still. No movement beneath the surface, no flash of silver, nothing. In 1998, the entire River Carron, a Highland spate river on Scotland's west coast, produced a total adult salmon return of 6 fish. Not 600. Not 60. 6. That number isn't a trend line on a graph or a projection from a model. 6 is what came back. 6 is what the river had left. And the question that number raises is the one this whole story turns on. When a river loses its salmon, can you actually bring them back? Or do you just delay the inevitable? The River Carron drops through steep highland terrain before emptying into the sea on Scotland's west coast. It is a spate river, which means it runs on rain. When a heavy storm rolls in off the Atlantic, water levels surge and fish move. But when conditions do not cooperate, nothing moves either. There is no reservoir feeding the system, no glacial meltwater keeping flows stable through a dry summer. The Carron lives and dies by weather events, and that makes it one of the most unforgiving environments a salmon can choose to call home. Through most of the 20th century, that unforgiving system still worked. Salmon ran the Carron every year, anglers fished it, the redds filled with eggs each winter, and the river kept cycling. Then, somewhere in the mid-1980s, the catches started dropping. Slowly at first, the kind of decline you can explain away as a bad year, then another bad year, then a trend you can no longer ignore. By the mid-1990s, the population was considered at risk of extinction. By 1998, the argument was settled. What happened to the Carron wasn't unique to the Carron. Atlantic salmon populations across Scotland had already collapsed by more than 70% since the 1970s, and the forces driving that collapse were hitting every west coast river simultaneously. Water temperatures were climbing, disrupting the precise biological triggers salmon depend on to time their migrations and spawning. Winter flooding, the catastrophic, red-destroying kind, was becoming more frequent, wiping out entire year classes of eggs before they could hatch. And out in the northeast Atlantic, the food chain that juvenile salmon need to survive their first years at sea was quietly unraveling, as zooplankton energy in key migration corridors declined dramatically across a period of decades. A 2024 study published through the Missing Salmon Alliance put it plainly that decline in zooplankton energy was significant, dramatic, and spread across precisely the ocean domains young salmon from rivers like the Carron were trying to cross. The Carron was getting hit from every direction at once. Too much rain at the wrong time, water too warm at the wrong time, and an ocean that was becoming increasingly hostile to any fish that made it that far. Into this situation walked Bob Kindness. He wasn't a government scientist or mainstream researcher. He was a professional fisheries manager who ran the Seafield Centre at Inverness College and managed the fishing estate at Atterdale. He had fished the Carron for years and watched it go from a functioning salmon river to something that barely qualified as one. He watched the catches fall through the 1980s and kept watching as they fell further through the 1990s, and at some point around 1995, he stopped watching and started doing something about it. Most people who understood what was happening to the Carron accepted the trajectory. The science pointed toward decline, the pressures weren't easing, and the conventional view on the one intervention people kept proposing, hatchery stocking, was that it made things worse, not better. Kindness disagreed, but the reason he disagreed and the specific way he acted on that disagreement is what makes this story worth telling. In 1995, Kindness and the River Carron Conservation Association made 2 decisions at once. They imposed a full catch-and-release policy on the rod fishery. Every salmon caught had to go back, and they launched a supplementary stocking program. Not one or the other, both simultaneously, because the logic was straightforward. Protect every adult fish that makes it back, while also putting more juveniles into the system. You can't rebuild a population if you keep removing the only breeding adults you have left. The stocking side of that plan was the controversial one. Not mildly controversial, genuinely opposed by the scientific and regulatory mainstream. The River D hatchery appraisal, published in 2016 and drawing on the available body of salmon science, laid out the consensus position clearly. Hatchery stocking was seen as harmful in most applications. Adult return rates from stocked fish ran between 0 and 1.8% in the published literature, meaning the overwhelming majority of fish released never came back at all. Worse, stocked fish introduced from non-local broodstock carried genetics that didn't match the river they were released into, weakening the fitness of any wild fish they interbred with. Natural selection had spent thousands of years tuning each salmon population to its specific river, its temperatures, its flood patterns, its food, and flooding that system with fish adapted to somewhere else or to a hatchery tank undid that work fast. Wales had already banned hatchery stocking entirely by the time the D appraisal came out. The spate was pulling back. Marine Scotland's default position toward new stocking proposals was skepticism at best, refusal at worst. The direction of travel in salmon management was away from hatcheries, and most of the evidence said that direction was correct. So what made Kindness think he wasn't making the same mistake everyone else had made? One thing mainly: the broodstock. Every other failing program had one version of the same problem. The fish going into the river were not from that river. They had been bred in hatcheries using genetics from elsewhere, crossed with fish from other systems, or held in captivity long enough that the selection pressures of the wild had already started to fade. The Carron program did none of that. Kindness took broodstock exclusively from returning Carron adults, fish caught on the rod that season, crossed with each other, their juveniles raised and released back into the same stretch of water their parents came from. No imported genetics, no outside stock. The river's own fish, multiplied, returned to the river. That distinction sounds simple, but it is everything. It is the difference between patching a native ecosystem and replacing it with something that looks similar, but is not. The philosophy Kindness built around this was what the RCCA eventually called a bridge approach, and the name captures it exactly. The hatchery was never meant to run permanently. It was meant to maintain enough fish in the system, enough returning adults, enough spawning pairs, enough juveniles in the holding pools, to keep the river's own cycle from going dark entirely. Once the wild population crossed back above a critical threshold, the natural process would take over and the hatchery could step back. The hatchery was not the destination, it was the structure keeping the river alive long enough to get there. Over the years that followed, roughly 150,000 juvenile fish went into the Carron through this program. Each year's broodstock came from that year's returning adults. The river was, in effect, producing its own recovery, just with a hatchery acting as an amplifier in the middle. Catches started climbing, slowly, in the late 1990s and into the early 2000s, from a baseline of around 11 fish a year. The numbers were moving, but they were small enough that anyone watching could still argue it was noise, coincidence, or natural variation. Nobody could prove the stocked fish were doing anything. For years, that was the problem. Then the science caught up. The problem with watching catch numbers climb on a spate river is that you can never be sure what is driving them. More fish showing up could mean the stocking program worked. It could also mean ocean conditions improved that particular year, fewer nets were running at sea, or the weather happened to cooperate during the migration window. Correlation is not causation, and the skeptics had a point. Without being able to tell a stocked fish from a wild fish once both were swimming the same river, the Carron's recovery was a promising signal, not proof. That changed when a team at the Rivers and Lochs Institute at the University of the Highlands and Islands started developing a technique called Parentage-Based tagging, spelled PBT. The concept is straightforward enough to explain in 30 seconds. Every fish entered into the hatchery program gets genetically sampled. Every juvenile released carries its parent's DNA. When an adult returns to the river years later and an angler clips a small fin sample, researchers can run that DNA against the hatchery records and find out whether that fish had hatchery parents, wild parents, or critically hatchery grandparents with wild parents of their own. It is a paternity test run across an entire river system, going back multiple generations. Starting from fin clip samples collected systematically since 2011, the team worked backwards through the data, tracking what happened to the 2014 broodstock cohort as those fish matured and returned. The Phase 2A results, published around 2021 and updated through 2025, answered the question the Carron program had been asking for 25 years. Stocked fish were coming back, not in token numbers, but in substantial ones. In peak years, fish originating from the hatchery program accounted for more than 50% of the entire rod catch. That is not a marginal contribution or a rounding error. That is the hatchery program being responsible for more than half the fish on the river in its best years. The genetic data also answered the second question, the one that actually determined whether kindness's bridge philosophy had worked. Researchers found no major differences in genetic diversity or inbreeding levels between the stocked fish and the wild-spawned fish in the same system. The local genetics protocol had held, but the finding that sits above all the others is this one. Wild-born progeny of the returning stocked fish was showing up in electrofishing surveys. The hatchery fish were not just coming back and getting caught by anglers, they were spawning successfully in the wild, and their offspring, genuinely wild fish hatched from reds in the Carron's own gravel, were surviving to the juvenile stage and appearing in the river's population counts. The bridge had been crossed, the wild cycle had restarted. Put the numbers in sequence and the shape of what happened becomes visible. 6 fish in 1998, a baseline of roughly 11 per year through the late 1990s, catches climbing slowly and then accelerating. A 2019 peak of 317 fish, not just a record for the restoration period, but a number that exceeded the Carron's catches from its previous high point in the 1980s, before the collapse had even begun. The UHI report's own language is careful, as scientific language tends to be, but the conclusion is unambiguous. Fish stocked in the Carron clearly survive to adulthood and make a substantial contribution to the fishery, and there are no major differences in measures of genetic diversity and inbreeding. The skeptics had been answered. The river was alive again. And then the ocean reminded everyone that the Carron story was not finished yet. 317 fish in 2019, then 85 in 2020, then 74, then 61, then 57 in 2023, according to Marine Scotland. Anyone watching that sequence wants to reach for an easy explanation, and there is not one. The Carron program did not change. The catch and release policy did not change. The broodstock protocol did not change. What changed is something no river manager in Scotland or anywhere in the North Atlantic has no power over at all. The ocean changed. A 2024 study published through the Missing Salmon Alliance measured zooplankton energy levels across the Northeast Atlantic going back 60 years and found they had declined significantly and dramatically across precisely the migration corridors that juvenile salmon from rivers like the Carron have to cross. Zooplankton feeds the sand eel. Sand eel feeds the post-smolt. When the base of that chain loses energy, the fish at the top of it arrive at their feeding grounds thinner, weaker, and far less likely to survive the 2 winters they need at sea before returning as adults. The Carron's stocked fish, the wild fish, every salmon from every Scottish river, they all run the same gauntlet. The 2025 Scottish National Rod catch figures made that gauntlet concrete. 28,020 fish total across the entire country, the lowest number recorded since records began in 1952. So the post-2019 decline on the Carron is not evidence that the program failed. It is evidence that even a fully restarted wild population, with its genetics intact and its river cycle running, is still subject to forces operating thousands of miles away. The bridge worked. The wild population crossed it. The fish that are spawning in the Carron's gravel right now are genuinely wild, descended from stocked fish. Yes, but bred in the river, shaped by the river, adapted to the river the way their ancestors were before the collapse. That process is real and it is running. But a wild salmon still has to spend 2 years in an ocean that is producing less food than it did a generation ago, and no hatchery program anywhere has a solution for that. What the Carron evidence did change is how other rivers are thinking about the narrow window between functional extinction and recovery. Marine Scotland's previous position, skepticism towards stocking as a default, has softened because of the parentage-based genetic testing data. Other rivers facing the same collapse trajectory the Carron was on in the mid-1990s are now looking at carefully managed local genetics programs as a legitimate option, where a decade earlier the answer would simply have been no. That's not a small thing. The Carron proved a concept that the science had written off, and it proved it with the kind of data that cannot be argued away. 6 fish in 1998. 317 in 2019. Wild-born juveniles are in the surveys right now. Can you bring a river back from the dead? The Carron's answer is yes, but only if you use the river's own genetics, treat the hatchery as a bridge rather than a permanent fix, and give the wild population enough time and protection to cross it on its own terms. The DNA does not lie. Fish that came out of that hatchery returned as adults, spawned in the river's own gravel, and their offspring are in the Carron today. Whether those fish survive long enough to come back and do it again depends on an ocean that nobody has figured out how to fix yet. That tension is the honest end of this story. The river is alive again. Whether it stays that way is a larger question, and the answer is not on any Scottish riverbank. If you want more stories about the people and science trying to hold the natural world together, subscribe and share this one with someone who needs to hear it.